Welcome to Echo 302, Study Session 11, Growth and Productivity. Introduction. Economic growth is defined as a continuous increase in output and aggregate income. Economic growth is used to measure the welfare of a nation over time or across country at a particular period of time. In macroeconomics, the study of economic growth is used to examine the behavior of the economy in the long run. That is, to find out the sources of increase in output in the long run. In the 1960s, the growth rate of output in Nigeria was around 7%, but went down to around 3% in the 1970s to 1980s. Yet in the 1990s, there was economic decay, while in the 2000s, the economy bounced back by recording a sudden jump, hovering around 7% growth rate per annum. The inconsistency of growth over time is not peculiar to Nigeria. Even in the advanced countries, growth rate over time has not been consistent. Why is this so? In a particular period, countries experience different growth rates. For instance, the average growth rate of France in 1974 to year 2000 was 1.6%, while that of the US was 1.9, United Kingdom 1.8, and of course Japan 2.4. Why are there differences in growth rate across countries for a particular period? What determines growth? Do capital accumulation and technological progress influence economic growth? If yes, how? The focus of this chapter is to introduce students to the development of models that can be used to explain economic growth. For simplicity and guidance, we shall adopt a simple version of growth, the solo growth model, to answer the question posed above. Objective. At the end of this lecture, you should be able to 1. Identify the sources of economic growth. 2. Appreciate the roles of capital accumulation and technological progress in economic growth. 3. Recognize that while capital accumulation produces level effect, technological progress produces pure growth effect. 3. Recognize that while capital accumulation produces level effect, technological growth produces pure growth effect. 4. Explain the relationship between capital accumulation, investment, and output. 5. Explain the fact that both physical and human capital development are growth enhancement, as well as number 6. Realize that when one of the nation's factors is held constant while others are varied, there will be diminishing return to the varied input content. In our earlier class, you were introduced to the concept of productivity. You will recall that sources of growth are the stock of capital, the size of labor force, the natural resource endowment, and technological progress. Increase in any of these except labor will raise labor productivity. For instance, increase in physical capital will mean that labor are having more capital to work with, and this will raise their output, that is productivity. Conversely, decrease in any holding labor constant will reduce the productivity of labor. To show this proposition clearly, we shall use the solo production function and characterize it. We will also use this production function to answer the questions posed in the introductory section of this lecture. The economy's production function. In developing any theory of growth, the starting point is to specify a production function. Note that production function, from macroeconomic perspective, is the aggregate or economics production function. However, we can use this experience of microeconomic foundation to understand these. Recall that production function shows how far inputs are transformed to output. Let us assume that the economy has two categories of factory input, that is labor and capital. Hence, the relationship between these inputs and output will be given as Y equals F of K and L. The function F, which tells us how much output is produced for a given quantity of capital and labor, is the aggregate production. Equation 11.1 assumes that capital and labor are homogeneous, which is not true in real life. Meanwhile, we shall hold on to this assumption because our focus is on how output behaves with a change in either capital or labor. In the model we are studying, the source of economic growth is technology. A country with a more advanced technology will produce more output from the same quantities of capital and labor that will an economy with primitive or obsolete or inferior technology. There are basically two ways of defining the state of technology: the range of product that can be produced and the technique used in producing it. The state of political, economic, and social institutions. We shall restrict our study to the first category and defer the second category till advanced class. Let us examine the properties of the production function specified in equation 11.1. The first experiment is to examine what happens to output if the size of both labor and capital triples. If output triples as well, we say production function exhibits constant return to scale. That is, 3y equals f of 3k and 3l. In general, one of the properties of the production function is that to be constant return to scale. If, for raising the scale of operation by factor lambda, output rises by lambda. That is, lambda y equals f of lambda k and lambda l. Now, assuming that labor is constant and will continue to increase capital, it is clear that subsequent increase in capital will add little to output. Hence, under constant return to scale, there are decreasing return to each factor, keeping the other constant. This is the second property of the production function specified above. That is, if the economy's capital is kept constant while labor force increases, there will be decreasing return to labor. If labor force is kept constant while capital increases, there will be decreasing return to capital. Output per worker in the economy. The other property just developed tells us that there is a relationship between output per unit of worker and capital unit of worker. To see this clearly, let lambda in equation 11.2 be written as lambda equals 1 over L. This implies that equation 11.2 can be written as 1 y over L, which equals f of 1 k over L and 1 L over L, which equals f of k over L and 1. Let y over L equals y and K over L equals K, we can write equation 11.3 as Y equals F of K and 1. This is called the production function in intensive form. Y over L, or Y, is the output per worker or worker productivity, while K over L, or K, is called capital per worker. Equation 11.3 tells us that labor productivity depends on the amount of capital per unit of labor. It turns out that holding labor force constant, the higher the capital accumulation, the greater the labor productivity. The behavior of Y as K increases is depicted in the graph below. Note that as capital per worker rises, output per worker also